Thanks once again, everyone, for your continued interest and for taking the time out to be here. As I mentioned, please do go ahead and add your name to the attendee list. And also, as mentioned, if you were not able to be on the previous call and the only other call that's taken place in the agenda document just below where you're putting your name, previous meetings, there's a link to the notes and the recording there. And maybe just sort of preemptively, some apologies for, we will, as you see in agenda item number 5, be sort of, I think the meat of this call, we'll be talking about the discussion paper that largely Andrew Hankinson has drafted, and maybe some apologies in advance. There's some inadvertent edits there that have doubled the size of that document. Half of it is real and half of it is a deleted version of itself. And so I've never seen this before, but we were unable to get rid of those suggestions. And so I think it's fair to say that we'll be sort of moving to another copy of the document, but there are quite a few substantive comments there too that maybe we want to address or capture before we move to a completely different document. And so maybe just very brief context setting, if it's not already clear, really what we've been trying to do and what we're continuing to try to do on this call as we sort of evolve this Oxford Common File System layout initiative is just trying to gain some common understanding of the space and some common understanding of what this current initiative is trying to achieve. And so on the last call, there was some very constructive contributions and discussion from folks at University of North Texas, some folks at CDL. It seems like it might also be helpful, and I think John Kunze mentioned this, maybe bringing in some others from CDL to talk about merit or other utilities or initiatives going on there. And also we heard from Notre Dame, Emory, UCSD, and Chronopolis. And then today we'll be hearing a little bit from HathiTrust as well. But so basically just trying to collect information around what is the prior art out there, what we don't want to be reinventing the wheel here. So this is an opportunity to maybe bring some best practices together, or some things that have worked, if we can consolidate them into sort of the next revision of a lot of what has already been done. So along those lines, if you do have suggestions for other institutions or other initiatives that would be informative in this context, please make a note of it. Probably most effectively now in the agenda document, maybe under the notes section or as a comment or something, but it seems like it's beneficial to everyone to add more voices to inform the initiative. So maybe with that as context, any comments or questions or observations before we plow forward with the agenda as laid out? All right. So with that, if you're okay, Andrew, I will pass off to agenda item number 2 to you.
Okay, so I think agenda item number 2 and 5 are kind of, they're both a bit, at the moment, I'm not really sure. I've set a few objectives or some ideas for objectives in the paper. But I just thought maybe I'll go through those objectives, and then maybe we'll go back to the discussion paper after the HathiTrust presentation. Is that what you were thinking, Andrew?
Yeah, I was thinking just a little additional context, and then moving on, giving the folks on the line an opportunity if there are some objectives that you don't outline here, make sure that we get them captured, and then give an opportunity for HathiTrust to speak to their system, and then we can dive into the discussion paper.
Yeah, I mean, I think I took from the last meeting that there's two really good points that have stuck with me. The first is that it's really useful to have a community to talk about these sorts of issues, and a bunch of people to just sort of bat around and have a common understanding and a common vocabulary. So I really appreciated that. And the second was the need to sort of make sure we separate software implementations from file storage considerations, which I think Mark at UNT made that point where they've migrated their management software much more than they've migrated the content of and the structure of their disk storage. At least that's what I took away from it. So the first thing I did in the discussion paper was just set out three objectives that are based kind of around those takeaways, which are a common approach to file and folder hierarchies. It seems like it's a really basic thing, but I think there's a lot of value to be had in sort of sharing a shared understanding of what that might look like. And then the other two are community of practice around how institutions are storing it, and how we can talk about these things, even if we don't adopt, if there's somebody says, oh, well, we don't want to migrate to a specific OCFL structure, that's fine. I think it's important that the community be open enough to encouraging other people with their specific implementations to come in and talk with us too. And the third is just sort of an ecosystem of software tools. So kind of being able to treat the file system as as a bit of a microservice where we can write tools against it, validation tools and other sorts of things, and kind of have the file system as an API itself for sharing, premise auditing tools or IIIF image servers or backup systems or things like that. So those are the three goals that I had set out. Objectives per se, so versioning objects and object structure and objects audits. I think those are sort of the implementation details. Those are sort of those would be what I would be looking at as part of this. How do we understand how to version, how file system based versioning looks like with plain files and folders. So those are my sort of objectives and goals, in which I hope to write down. But of course, I'm open to lots of other suggestions and ideas from others. So I think that would be item number 3, right?
That is exactly item number 3. So if there are at this point things that people feel would be important to integrate into this effort that maybe haven't been highlighted or even mentioned yet.
Wow, we got it right the first time.
I think it's a subcategory of versioning, but deletion and how to deal with deletion. Maybe Moab knows more about that, and I don't know Moab. But I think that'd be sort of interesting. And then I intersperse some stuff here about metadata throughout. And we can get into that when you want to.
Sure. Do you mean like, so say tombstoning, that sort of thing?
Possibly, or maybe not allowing deletion. There was actually a statement kind of like that in there, and I was kind of curious about that, but I haven't gotten that deep yet.
Yeah, I kind of think we need to allow deletion just for like, if somebody gets hacked and all of a sudden their institutional repository becomes a source of pornographic materials or something like that. I mean, we can't just say, oh well, we got to keep that for perpetuity. So I think there are use cases for deletion, but obviously, they would need to be appropriately caveated and said, only in these cases should you consider that.
Okay, I like that.
Just an example from when I was at Stanford, we did have a case where there was a request for a deletion. Somebody deposited something that they did not intend to ever hand over. It just kind of got shuffled in with a bunch of stuff. And Moab doesn't have a way of deleting. So we weren't really sure how to handle that. But and then I left, so I don't know what happened.
It's probably still there.
Found a way.
It's totally the best way to handle it. But it seems like when Emory recently, and like 2 weeks ago, created a retention policy, and we explicitly defined deletion as a very abnormal event. So decommissioning an object and making it so that nobody except for people who had access to the file system seems like something very separate than, say, I don't even want to know that that thing has ever existed on a server that we have, right? Those seem like very different things. And so we allowed for that. And the only way we said in our retention policy that we would delete something is if we essentially would be sued into oblivion. I mean, we had nicer language than that, but if we're sued into the oblivion, and in that event, that's a decision that the university librarian must make. And then we would document why that decision was made in various different ways.
Yeah.
But I think there is a distinction between decommissioning so people can't see it, and then really wanting to delete it because you are paranoid and afraid of what will happen if you don't.
Yeah.
Yeah, we're writing a service layer for Moab right now, and we're explicitly not including any delete clauses because we do not want an automated way to delete content off the file system.
Okay.
Good. I've got into some hairy discussions with archivists here about what they feel they should or shouldn't be able to delete. And I'm as a systems person, I don't want anything deleted because it messes with the integrity of the system. But they should have full control over access. So we go back and forth on that.
Yeah.
I'm wondering if another goal of this is Evelyn McClellan from Artifactual, and I wasn't at the last meeting, I apologize, but if another goal of this might be some kind of human readable content so that that a person can actually like open up a text file and understand what this object is. And an example we had was someone who asked, could we have something like an ape README file, which just tells us what the structure of this ape is and what are all the components?
Thanks, Evelyn. I think so. So the intention is to make it completely human readable. I think you should be able to browse the whole file system with nothing but your, Finder or command line tools or Windows Explorer. I think the current discussion paper, the way I structured it, there's a JavaScript object notation JSON file, which is about as human readable as XML. And it would contain a manifest of all the files in there and the structure and the versioning and all of that. So, and that would be in plain text. So it would be, I think the intent is that, you have all of the files, everything would be, as you see it, as you might have any other file or folder, and then a bit of human readable administrative structured data in order to talk about the contents of that.
And that would be obvious. You'd sort of open up this package and right away you'd see, oh, this is what I should read in order to understand what this package is.
Every object would have that. And I think one of the key components of this that I think the first thing that we do after we get the spec is we write a validator. And it would definitely be an error if you find a folder in there that didn't have that description. So validation would be top priority for all of this.
Right. Thank you.
Yeah.
So can I ask a question based on Evelyn's comment? Because I literally just walked out of a meeting having this conversation. So we were talking about readability of an ape in relation to how content is grouped.
Mm-hmm.
So like you should group all your identifiers together because you don't want to have identifiers living in 8 million different places. You want to walk in and know, like, I should look in this, like see something like identifiers and know I can open that up and see a list of identifiers.
Mm-hmm.
Is that a concept that, and this may go back to the comment that I made to Andrew about deprioritizing metadata. Are we really deprioritizing that, or are we saying that the metadata is itself files within the object structure? Does that?
Yeah.
That wasn't very coherent, but I hope you kind of understand.
I think I get what you mean. I came up with a bit of phraseology in responding to you and Declan just on the comments there. Is that I think what we're trying to do here, what I tried to do in the paper, but I think what we're broadly trying to do and what I'd like to see us try to do is define buckets. We're basically defining buckets, and what you put in the bucket can be mostly up to you. So I think metadata as files, yes. I mean that, if you're Fedora, if you're DSpace, if you're ePrints, if you're any of these other things, you have an OCFL compliant layer, you should be writing your RDF, your METs, your DC out to the file system, and you should be doing that on every version of the object. So that should be part of what it means to be fully compliant. I guess what I meant when I was sort of deprioritizing metadata is that I don't think we can standardize that. I don't think we can say Fedora has to write out METS files, and just the same way I don't think DSpace has to write RDF.
Oh God, no, we can't even all agree what should be in Dublin core level.
Yeah. So I think buckets and not contents of buckets is what I'm trying to what I tried to communicate in the discussion paper. But yes, definitely metadata should be there. I mean, this initiative is driven by our own requirements at Oxford that we should be able to plug in any system, check out the code from our Git repository, put it against an OCFL drive, and it should be able to read everything in from scratch. Now, reading it in and understanding it is two different things, but I think the first step is just to understand the file structure.
Just to be a little pedantic too, using the word should when I think you should use the word must for this, and without prescribing the serialization, it has to lay on the disk somehow.
Mm-hmm.
All metadata, including description metadata, has to lay on the disk. And we can argue for years about the best way to do that, but it has to be there or it can't be considered OCFL.
It sounds like you want to be on the editorial group, Declan.
Just delegate it.
Yeah, I think that's something that we should definitely keep in mind. I mean, I think there will be a very fine line there about what it is and what it isn't. I mean, if you're only storing metadata and no files, that's one thing. But what happens if you're storing files and no metadata? You have that case. I think gathering these use cases is really going to be key to the initiative, and seeing what people are wanting to store, what people are wanting to capture, what people are wanting to serialize out will be that'll be a key component of our work as use cases.
could you not be inclusive and just say whatever metadata there is on the object has to serialize? One of the options there is no metadata. Some of the options could be EAD, and if it doesn't serialize well, then it's a copy of the frickin' EAD.
Yeah.
Until they figure that crap out.
Yeah. And I think we even have that use case here where we're going with archive space, and archive space is EAD, and that's what we have to work with. So.
All right, so maybe bringing the conversation back to other missing elements here from people's perspectives before we continue on.
Mm-hmm.
I just added something to the chat that's relevant to the previous discussion, but I don't want to hold things up. Might be something to toss into the ring regarding file system versioning. Old-fashioned, humble, and stupid, but it kind of works. Might inform future discussions.
Yeah. Okay. Thanks, John. I'll make a note of that.
And maybe along those lines, in a meta sort of way, if people can add notes here to the bottom of the agenda page, just so we capture some of these elements.
Oh, I see that it's already added there, so thanks.
Yeah, I took my own advice. Yeah, so how about, I know, Aaron Elkis, you've put together something here. If it's okay with you, maybe we can transition over to
great.
Yeah, that.
Yeah, I have some slides here, so I'll put a link in the chat and also do the screen share. There's the link. And I'm going to share my screen here. Okay. There you go. All right, is that visible here?
Looks good.
Great. So I'm Aaron Elkis. I'm the technical lead for repository services with HeidiTrust, and physically located here at University of Michigan. And I'm going to talk a bit about what our storage is for HeidiTrust, and a little bit about what our needs were that led us to making some of those decisions. I'm going to give a brief overview of what HeidiTrust is for anyone who might not be super familiar with it. Talk about some of our principles, talk about how the storage is actually laid out and how applications interact with it, and then briefly talk about some of the limitations with our approach. So HeidiTrust was founded in 2008 by partnership of University of Michigan, California, especially CDL, and the Big Ten Academic Alliance. It now has over 100 institutions. We have about 16 million digitized books now, which is 844 terabytes, 5.9 billion pages, and 17 billion individual files within all of those digitized books. The vast majority of this material was scanned by Google from our member libraries, but we do have some that was also scanned by Internet Archive or the member libraries themselves. But overall, the content is quite homogeneous, which has affected some of our decisions. About 37% of this material is public domain or otherwise viewable in HeidiTrust, and the rest is search only. So it's discoverable but not viewable. For our actual infrastructure, we have two 13-node, 1.7 petabyte Iceland clusters. One is here in Ann Arbor, and the other is at Indianapolis, which is also kind of an active copy, but that copy is read-only. We write from here to only here at Ann Arbor, and the rest is kind of system-based replication. And then we have tape-based backup of that as well here in Ann Arbor. So from the outset, our primary design concern here is really scalability. Scalability of ingest and scalability of being able to audit it. At our peak growth, we ingested over 50,000 volumes, or about 2.5 terabytes per day. We run weekly consistency checks and quarterly full checksum audits over the entire thing. One thing that I think is maybe a little bit unusual is that the content is completely separated from the descriptive and rights metadata. The descriptive metadata is updated typically more frequently than the content, and it's stored in an entirely separate system that's currently running at CDL that I'm not going to talk about today. And the rights metadata is also handled separately and is based primarily on that descriptive metadata. That helps us kind of minimize the number of changes that happen to the content, but it does mean that there's essentially two separate systems that are required to fully recover if there was some kind of disaster. And one major kind of gap between what we do and the requirements laid out in OCFL is that we have no support really for versioning at all, primarily because it would be cost prohibitive to retain multiple versions of these things. As Google makes improvements to volumes, we do re-ingest them. At our current rate, we would re-ingest the entire repository once every 5 years, and so that means that if we were keeping versions right now, we'd be looking at double or triple our storage cost, which is just not tenable for us. So storage layout, the way things are laid out on disk is pretty simple. We have a peer tree per namespace, where a namespace is roughly someone who's generating identifiers. So as an example, this is a volume from Purdue. It's identified with a barcode. There's a peer tree under each namespace. And at the terminal directory, there's a METS file with some metadata, as well as a zip file with all the actual content. In the METS file, we have premise metadata, but we only update that for actions that actually change the object, not for the audit. Again, that's to kind of minimize the number of times these things need to be rewritten or touched. That also has the file manifest. We only use MD5 checksums just because that was a decision made originally, and we haven't had a need to change it. The main goal is to protect against corruption, not really to protect against unauthorized changes to the object. It also has some metadata needed for display, but it doesn't have any descriptive rights or technical metadata embedded in it. And then the zip file has the actual content. Within the zip file is just a flat structure with one file per page that's very specific to the nature of this as a repository for digitized page images. And then it also has what we call a source METS with some kind of archaeological information in it, which does include kind of a snapshot of the descriptive metadata at the time it was ingested, but that's not really accessible in any way within the system. It's primarily for disaster recovery. So interacting with this, the file system content with the peer tree, the METS, and the zip is essentially the API. There's only one application, the ingest process, that has write access to the file system, and that's kind of controlled at the server level and with file system permissions. And there's a number of applications, including full text indexing, page display, and auditing that I mentioned briefly that read from the file system. But they all kind of have their own way of doing that. It's not mediated by a common software layer. So it's a pretty simple and scalable system in terms of being able to write to it. It's pretty transparent. If you were just getting the METS and the zip, you could pretty easily figure out how the object is arranged. You might have to actually look at the content to see what it is, since the descriptive metadata isn't included with it. The design isn't really concerned with flexibility. It handles only digitized book material. We've started working on handling some born digital stuff, and that's challenges some of the baked-in assumptions about the structure of the METS and the zip, and changing that is a pretty big undertaking. But the overall layout with there is a METS and a zip would be kind of unchanged. The lack of flexibility is true about the companion descriptive metadata system too. It only handles MARC data. And as far as the content, like I mentioned, there's really no versioning support. We have old versions on tape for 6 months, but those aren't accessible except in kind of emergency recovery situations, just because indefinite retention for all the versions and having those online or even backed up via tape would just be cost prohibitive at the scale that we're operating at. And that's all I have. Does anyone have any quick questions before we move on?
You mentioned that you only have premise events for actions that change the object. What kinds of actions would those be?
Primarily when the object is re-ingested, or there's some kind of metadata uplift or file format migration, the premise would be updated. But in particular, we don't retain a record in the premise when there are auditing actions.
Mm-hmm.
We do have kind of a separate database that lists the last time an object was audited, or the last time it had its checksum check.
Yeah.
Yeah, but that's not stored in the premise, just because then we'd be constantly having to rewrite those files for the entire repository.
So when you create a new version of an object, if you do a migration, do you keep the old version as well, or is that? Oh, I see. So
it's backed up to tape, and the old version is just completely overwritten.
Okay, I see.
Yep.
Thanks.
Do you store a record of when that happened? So when it was updated?
Mm-hmm.
Yeah, the premise does get updated when things like that happen.
Okay.
Yeah. And I'm thinking about sort of the separation between the descriptive metadata and the content, and just sort of trying to reconcile some of the common risks associated with that, and them being more fundamentally separated over time. And I guess I'm just curious. That seems like a pretty significant design decision, and one that
right.
Yeah. So I'm just sort of some thinking behind that, or if you have any additional comment there.
Yeah, I think in some ways it's kind of a historical decision, just because of the way things were originally designed, with the metadata being managed originally in an ILS, and now there's kind of a separate, more preservation grade system for that. But it was always envisioned that these things would be updated quite separately. If there's a cataloging error, that doesn't necessarily affect the content of the book. And so really the desire was trying to avoid changing the actual content so much as possible. And if I don't know that we would make the same decisions if we were designing this again from scratch, and I certainly agree, and I think that we realize there is a preservation risk by doing that, which we do try to mitigate somewhat by including the snapshot of the descriptive metadata as it was when the object was ingested. But yeah, I certainly recognize it's not a very typical approach.
Yeah, thanks, Aaron. All right, and thanks again, Aaron. Are there any other questions or comments here?
I have one question, and that is the auditing, does that happen just at the zip file level, or do you actually look in the zip files? I'm just curious.
It currently only happens at the zip file level. We have thought about looking inside the zips and checking every file in them, which I think that would be doable. We just haven't done that yet.
Mathematically, what would that get you?
It would prove. Sorry, I'm getting an echo. It would prove that you had written the zip file correctly, that your ingest processes were working. I mean, the METS has the checksum for the zip as well as the individual files inside it. So if there was a problem in that process, then checking inside the zip would find that. But
gotcha.
Well, if the zip file checks out, then the contents within the zip file have to check out as well.
Well, that's not necessarily true, because I think there's kind of a race condition between when you compute the checksums of the thing that you put in the zip, and then you create the zip, and you're kind of trusting that that zip was created correctly, and then yeah, you put the stuff in the zip and then you get the checksum of the zip, but you haven't really proved that you actually put in the zip what you think you did.
Right.
There's obviously a way to check that, in that once you've made the zip, you make a copy of that zip, extract it, and verify the contents.
Right, exactly. But we aren't doing that currently. But
there's a level of paranoia that most people don't rise to.
Yeah. And I guess one thing I should mention is that in the original system design, it didn't have the zips, it just had the files flat on disk. But as I think has been mentioned in this group before, some systems, especially the Isilon system that we use, don't deal well with very large numbers of small files.
Well, maybe for the sake of time, we should dig into the current draft of the discussion paper for OCFL here. But yeah, I think having maybe fewer presentations like we were seeing here with HathiTrust enables a little bit more discussion. We had more of a shotgun approach last time, so just something to think about. But so I don't know if you have a way you'd like to introduce this, Andrew.
Start at the beginning. So I don't know what you did on your Christmas break, but this is what I did on my Christmas break. So you've all seen the paper, obviously, and I've gotten some really great comments. Thank you to all the people who have commented on that. So I thought Andrew and I thought we would go through this, maybe try to explain some things that I considered in here. I mean, I really hope that this will. I didn't really know what I was talking about until I sat down and put this on paper. So I'm hoping that this will help inform any discussions going forward. I should also point out that maybe if you haven't seen it, there is a link to a gist at the top of the design principles section in there that actually makes plain the type of structure that I was talking about. So rather than just talking about it in text, I prototyped up what it might look like in real life, so to speak. Right. So I reviewed, to start with, I thought it was important to go through some of the prior art. I really appreciated John Kunz's efforts around the red and D flat things, and that's sort of what inspired me to begin with. Then the Moab, I think, is a nice improvement on that. And I'm aware that here, at Oxford, we've had our own approach to this a few years ago that for one reason or another is we no longer really do, which we call data bank. So I think there's a lot of good prior art that we can consider. I think it's important to use the Linux file system hierarchy standard. I don't know how many people are familiar with this, but basically it's files and folders. How do they relate? What are their ostensible function? I mean, they're really different between different versions of Linux, but there's some sort of shared understanding that, configuration files go as in /etc, that sort of thing. So, so the idea of a standard folder hierarchy really kind of owes a lot to this. And as I mentioned earlier, I think the idea that we're creating buckets is really the one that, if I were to distill it down to one thing, that would be what it would be. How do you create a bucket that supports a lot of the functions of a preservation level file system and repository? And if we didn't have to support versioning, the bucket would be pretty easy. It would be a folder with stuff in it. Adding versioning to that makes it a bit tricky. But at the core, I think there needs to be some sort of understanding that even with versioning added on top of it, the whole thing needs to be human readable, plain objects. If you wanted to, you could probably come up with a really complex command line pipe system to read an OCFL object. So I think that would be the goal, is, if you wanted to sort of pipe together grep and CD and ls and all of those things to read out a version, you could do it. No software needed, really, other than the software that comes with it. I mean, yeah, you have to have some software somewhere. Right. So in thinking about these buckets, I think there are a few things that need to be put out of scope. And that is, unfortunately, I think, not that I think that they're not valuable, but I kind of am looking at this as a bit of a micro specification. Microservices need micro specifications, and that micro specification will be a very limited. This is the only thing that we're talking about. I think there are some valuable things around logging, logging of events, pair tree, how pair tree is created. Both of these, I think, are complementary efforts to the OCFL efforts, but I'm not really sure that. I think we can actually break those things out and talk about those things separately. Same with metadata. I'm all for getting some sanity in what metadata standards we use, but I don't think we'll be able to solve that in our efforts. So I'd really like to keep it to files and folders, and what do we need to make those make sense. So let's see here. How do I tell what page I'm on? I guess in Google Docs.
Bottom of page 3.
I'm at the OCFL initiative in following the example of Moab and CDL. So whatever page that is, I guess. 1, 2. Yeah, I guess it's on page 3. Yeah, so just here I've laid out a few things. File system independent of software implementations, no special software, work with a wide variety of storage systems. I really appreciated those who came on last month's call, talking about using S3 and object stores, because I think that's a valuable target. I also learned in the process of writing this that those S3 stores basically have a flat hierarchy. On disks, you only have so many folders you can stick in another folder. On S3, you can have as many folders in one hierarchy as you want. And I think that was important for me, at least conceptually, to understand, because it really provided a foil against thinking in terms of putting things on a disk. And the somewhat contentious permit the full restoration of an institutional repository. I think this is one of the design goals that we have locally. And I feel like that needs to be caveated quite heavily, in that the key word here is permit, that it won't support, it won't do all of the things that you want it to do. If you're migrating from Fedora to DSpace, it doesn't make that, or DSpace to Fedora, it wouldn't make that transition easier, in that you'd still have metadata problems. You still have to write the way the two pieces of software understand their digital objects. What it would mean, though, is that you could potentially take one piece of software and point it at another piece of software's disk storage system, and then it would do as much as possible to understand all of the things that are in that. And again, I don't know where the line is there, but I don't think we're going to be able to support the universal metadata format for all of these institutional repositories. I think that'll be the trickiest bit, is how do we make this work across everywhere and everyone's systems. The design principles, I mean, they're pretty straightforward. I think basically avoiding anti-patterns is what it was, what I tried to do. How these things, what sort of things do you not want to support in order to make sure that you can support as much as possible. I don't know if that makes sense, but basically, I took the decision that if the more you specify, the more specific your implementation will get. And again, if we want to build something that is software agnostic, keeping it as general as possible would be nice. Let's see here. Right, so file system roots, I won't go through all of this because it's kind of boring. And I think it will get into the spec. Once we get into the specification parts, then it will be, and there will be other times to get to the details of this. One of the biggest criticisms or critiques that I've had have been the proposal for how the versioning works, and whether we use SHA-256 checksums or et cetera, and the fact that in the current proposal, the file that determines the versions isn't versioned itself, and I think that's a really good thing to try to work around. The idea of the versioning, when I was looking at, I sort of looked at the Moab specification, and one thing that sort of maybe Julian or somebody can correct me, but that the version in Moab has to be sort of computed almost from all previous versions, rather than actually just read straight out. So I wanted to, at least in the Code for Lib paper, that's what it sounded like it was doing, where it had to sort of identify what things had changed from version to version and then reconstruct the object from there. So the structure of the versions file was meant to address that. How do we reconstruct an object just by reading a single file and then traversing checksums?
Okay, so I can address that really briefly. Yes, you're right. The versions in Moab are basically diffs. So to get to version 7, you need to diff starting from version 1 all the way through. It's actually not that hard. The manifest inventory file and the signature catalog in the most recent version is usually a one-stop shop, and you can work out what file. If you're just after like one or two files, you can just look in the signature catalog and work out exactly what it is that you need.
Okay.
But yeah, it's not ideal, but the advantage is we save a ton of space on disk.
Right.
In an Archivematica ape, we do versioning via the METs. So the METs file allows you to incorporate versioning information about the contents of the METs file, and then the METs header allows you to say that the METs file itself has been versioned.
Mm-hmm. Great, thank you. So I think that's about it. Yeah, I think the only other thing was I'm still not sure where the line is between avoiding any particular metadata standard and supporting things like versioning in METs. You know, I'm well aware that not everybody wants to use METs. Or not everybody wants to probably use anything. You know, you'll never find one thing that everybody wants to use. But that line of, you know, what formats are out there. I know we use METs internally, but I'm also aware that it's not the best. You know, there are significant bits of overhead for reading and writing these things. And if your access, so, you know, if you're intending to write a IIIF image server that sits on top of your file system, it will need to respond pretty quickly. And if that requires opening up and parsing a METS XML file at sort of request time, I think, you know, that will have an impact on how well you're able to serve your users' needs. Mm-hmm. So, but again, I think use cases and other bits of feedback from the community will be really useful to sort of scope that out. So I think that's it for me. I think I have nothing else to say. You'll see at the bottom in the implementation patterns where I sort of threw together a few imagined scenarios, and so I'd be really really interested in hearing other people's imagined scenarios or real scenarios even. So I think I've talked long enough, Andrew.
Yeah. Well.
Yeah.
It seems like there's a lot more to be said, and but I think just being aware of our limited time here, I'm thinking about moving this forward and what we want that to look like. So it seems that we have this discussion paper as a seed for what might evolve into, or will, in one form or another, evolve into a specification document. Ideally, that effort will be informed by the community of interested stakeholders, in large part represented by folks here. It seems that particularly folks who have built systems already, and we've heard from several already over the last two calls, I think it would be extremely beneficial to note where the discussion paper is diverging from practices that are currently in place, and specifically practices that are currently in place and desirable, or they seem to be working well. We don't want to be missing out on constructive behaviors. So I think folks who have put together implementations, getting that sort of feedback would be extremely valuable. Also, as I mentioned before, if folks know of other work that's out there that we should surface, please let that be known. But I'm sort of thinking about the next call and subsequent calls. And in agenda item number 8, you see that notionally we have a next meeting scheduled for next month, same time on a Friday. but maybe we've been doing sort of context setting and shared understanding work over the last 2 calls, starting to delve into more of specifics as we see in the discussion paper. So maybe on the next call, if in advance of that, maybe some more detailed review of the discussion paper, and then more detailed discussion of the evolving discussion paper, and making sure that other elements are brought into it. And then as a part of that, as it mentioned in agenda item number 7, thinking about an editorial team, because we want this to be as transparent and open and inclusive as possible, and having a team of folks who are helping to shepherd this forward, so it's not just on the shoulders of 1 or 2 people. And then we can also be talking about timelines and when we want specification to start to land, and ideally work with implementations that are implementing that specification. So I propose that as a plan going forward. The suggestion specifically, well, I've made several of them, but thinking about the next call, talking about the details of the discussion paper, and making sure that other elements are incorporated there. So we are at the hour. Any immediate reactions or any parting comments before we close?
I was just going to say that with the discussion paper, we'll probably move it to another Google Doc just to get rid of the extraneous edits. And we'll try to leave a link in that discussion paper to the next one, just so that you can follow it. So yeah, watch this space there. We'll try to also keep the comments, because I really appreciate the comments.
All right. Perfect. Well, thanks everyone, and talk to you next time.
Thank you.
Yeah, thank you. Bye.
Thank you. Bye-bye.
Thanks very much.
Bye. Thanks.
Bye.